Okay, hopefully everybody's back now, and I hope you had a chance to look over this problem. We're going to start with this particular problem and see how we would do an in-between. This is a between probability, and see how that would look with the 4 steps. So I'm going to do the camera here. Give me a second. Okay, so this was the problem. It's actually problem number 4 in the assignment. And so what we have here are 2 data values that have to be changed to z-scores. So let's look at the 74 first. So on both of these, with a z-score for a data value of 74, you're going to have, so I'm going to do this one. You should have 74 minus the mean divided by the standard deviation. So remember, those parentheses are important. So I'm going to have 74 minus 87 divided by 4. Negative 3.25. Wow, that's unusual, isn't it? Because that's less than negative 2. Did you guys get the same thing? Raise your hand if you got that for the z-score for 74. Yeah? Okay. Okay, good. Okay, then for the data value 81, our z-score would be 81 minus 87 divided by 4. What'd you get for that? So let's see. I got for this one, for the z-score for the 81, I got negative 1.5. Did you guys get that for that z-score? Okay, good. Then the next thing you should have done was rewrite the question here. So now the question becomes the probability. Instead of x between 2 numbers, it's going to be z between 2 numbers. So we're going to put that one over here and the negative 1.5 over here. So that's our new question. So when we draw our picture, this is our z-axis. We're going to put both of those z-scores on our picture. So, and they both happen to be to the left because they're both negative. So if 0 was here, and it doesn't matter if you put them, if you place them perfectly, just make sure that they're relatively in the right place. So negative 3.25 should be further to the left than negative 1.5. So there's where I put the z-scores on the axis. And then I'm going to shade the area that I want. I'm going to shade in orange to be consistent. And I want the area that's bigger than this blue z-score but smaller than this. So what I'm really looking for is this area here. Always shade the area you're looking for. And then when I look up area to the left, I'm going to look that up for both z-scores. So I'm going to use the z-table and look up both of these areas. The area to the left of negative 3.25 and the area to the left of negative 1.5. So use your z-table. Hopefully you have that printed off or pulled up on your computer. And I'm going to write these down, and then I'll take some questions before we do the final answer. So when I look up negative 3.25, that's a pretty tiny number. That's .0006, 3 zeros and a 6, yeah. And negative 1.5, since there's no number there, that number in the hundreds place is 0, so that's the first column, negative 1.5, and that's 0.0668. So this is what our picture looks like. So I'm going to stop for just a second and see if anybody has any questions about what we've done so far. If you don't have any questions, if you have the same thing, then see if you can figure out what our answer is. Remember, the answer, the thing we're looking for is that area in between. This is our question right here. What's that area in between? Kendra, did you have a question?
No, go ahead. Keep talking. Sorry.
Okay.
I'm just kind of still trying to find the answer.
Okay. So, Christina, is that what you got for the final answer? And if so, tell me what the work is for it. So, we were looking for the probability that the z-score was between negative 3.25. Oh, wait a second. Did I look up the right thing? Negative 3.2. Yeah, I did. And negative 1.5. So, Christina, if that's what do you do?
So I can't find the z-score to solve the problem for the 1.5. I guess I didn't calculate something right.
Do you have the z table, Kendra?
Yes, I do.
So on the z table, if you're looking at the area to the left of negative 1.5, you're going on the negative page of the table, negative 1.5, and the number in the hundreds place is 0 because it's just negative 1.5, and that is 0.0668. You see that?
Oh, I guess I don't have the paper yet.
Okay, well, you can't do any of the problems without this table. Okay, so I'm telling this to everybody. Unless you have this table printed off, or you bring it up in my stat lab, or bring it up. I have a copy. In fact, I have this exact one is in your Unit 3 folder under Lessons. So you can just bring it up if you want to, but you won't be able to do that for the test. You're going to have a printout of the z-table for the test. So Christina, you said you subtracted 0.006 from, right, so you're going to take the bigger area, which was 0.0668, and you subtracted 0.0006. So that's our calculation. That would be an important thing for you to show me in your work. So 0.0668 minus 0.0006 is 0.0662. That's what I got. Let's see, and that's what Christina said. Yes. Okay, Kayla, do you have a question?
Yeah, I kind of don't understand 100% how you know, like, how to calculate it.
How to calculate what?
Like, I know you have, yeah, I know you have to do, like, calculate the, like, P part, but how do you know you have to use the z-score?
Because that's what the table gives you. This table that we're allowed to use that gives us areas, which are the probabilities, it's based on z-scores. So when you know the data values, and the reason you know they've given you data values is because it says X here.
So I'm basically just substituting them for the time.
Yeah, so you're converting those data values to z-scores, which is basically the same as finding how many standard deviations they are above or below the mean. That's the z-score. Every data value has a z-score that's based on the mean and standard deviation for the data set. So once you know the mean and standard deviation, you can find the z-score for any data value in that data set. And then, so you find those z-scores. This one we had to find 2 because there were 2 numbers in the probability question. And so that first step, we'll calculate the z-scores. Because until I have z-scores, this table is useless. Okay? So I calculated the z-scores, and yes, all I did was substituted in place of this 74, I put the z-score that I got for 74. In place of the 81, I put this z-score that I got for 81. So all I did was rewrite the problem. I rewrote this problem, substituting replacing the data values with their z-scores. When I do that, then that means it's not x's between those 2 numbers. Now the question is, what's the probability that a z-score is between these 2 numbers? And that puts me in a position to use the table. So I draw the picture, and the z's go along the bottom, and I have to locate these as if they're on a number line. So if 0's here, all the negatives are to the left and all the positives are to the right. Negative 3.25 is further down than negative 1.5, so I just put them on there. I don't have to put them in the exact right spot. I do want the one that should be on the left to be on the left, though. Okay?
Okay.
So I put those on there. And then since this is saying what's the probability z is between, I shaded the area in between those, which means I don't want any of that area, and I don't want this little piece right here. Then I can use the table, but the table only gives me one thing. The table only gives me area to the left of a z-score. It doesn't give me anything else. So I come over here, and I just found the 2 numbers that it had for these 2 z-scores. And this, when I looked up negative 3.25, cross-referencing negative 3.2 and 0.05. So I'm looking on the row that said negative 3.2, and I'm looking for the column that says 0.05. The number in the hundredths place will tell you which column. And I'm cross-referencing that, and that number was 0.0006. And that gave me the area to the left of that z-score. And I did the same thing for negative 1.5. So for this one, I'm cross-referencing negative 1.5, and I'm looking down the 0.00 column. And that gave me the area to the left of that z-score. So I need everybody to make sure, and you're not going to be able to do this if you don't have a z-table in front of you. So write these 2 z-scores down, and I want everybody to make absolutely sure that you can find these areas on the z-table being the areas to the left of those z-scores. And they're both negative, so they're both going to be on the same side of the table. You do have to be careful that you're looking on the correct page of the table. These are both negative, so they're both on the same page. So let's stop there for a second. I want everybody to make sure. If you haven't pulled up a z-table, if you haven't been using it, if you're just watching me, that's not good enough. I need you to pull up the z-table or look at a printout. You need to get a printout of that z-table one way or the other. That's going to make everything so much easier. All right? And I want you to make sure you know how to find these 2 areas for these 2 z-scores. Okay? And basically all these areas, guys, they're basically related to that empirical rule that we already learned, but it does it for every z-score instead of just the 68, 95, and 99.7, which is just positive, plus or minus 1, 2, and 3. That's all we had with the empirical rule. Now we can look up any z-score and find the area to the left by using the table. Then over here for your final answer, when you're doing an in-between problem like this, the way you find an in-between area is always to take the bigger area, that would be all of this area under the curve, and subtract off this part that you don't want, which is this number. So this orange shaded area is the same thing as taking everything to the left of that one, and then basically chopping off the area to the left of this one, and that leaves just the area in between. That's why we subtracted, and that gave us the area in between. Kendra?
So I saw on the Z table, I did look for the numbers, but I was wondering, do I need to use all the numbers in the row or just one?
You're
Because I
going
know
to
it
call
says negative 1.6, and it's all 0.00, or is it the other numbers too?
the numbers across the top. You just look at the column that has the correct number in the hundredths place. So you find one row and one column, and you look to see where that row and column intersect. There'll just be one row and one column.
Yeah, okay, let me look.
So when I'm looking up negative, everybody look up here for a second. And I look up, when I'm trying to look up negative 3.25, I look up this row, negative 3.2, and I look up the column for 0.05 because there's a 5 in the hundredths place. This one row and this one column. And the number that is there at the intersection of this row and this column is the area to the left of this z-score. And then I did the same thing for negative 1.50. So if I'm looking up the area to the left of negative 1.50, this one, I look up negative 1.5 under the z, and then across the top, since that number is a 0, I only look at the 0.00, which is the first column. I'm looking here, this row, that first column, the number that's in there is 0.0668. And that's the area to the left of that z-score. Anisha, I'm going to need to turn your mic off because I'm getting feedback. Thank you. All right, let's go on. We're going to do another example before class is over. I think I have, let me see how many. Yeah, I have one more. So let's do the last one. And hopefully if it hasn't gelled with you yet, it will on this last one. Now this one has many parts and you can actually see the answers here. So when you watch the recording, you can go back to this and see what the answers were so you can see if you're doing it right. Probably not going to have time to do every single part of this, but I'll do however many parts we have time for, and we'll know if we got it right because I happen to take a picture of the problem with the correct answers. I'm going to have to look up really close So this one says the mean incubation time for a type of fertilized egg kept at a certain temperature is 20 days. The important number there, guys, it says the mean is 20 days. The mean incubation time is 20 days. So I'm going to put mu equals 20. And I can't remember. This is problem 14. So the mean is 20. And it says suppose incubation time approximately normally distributed with, and it looks like I got the standard deviation. I didn't write down the standard deviation. It doesn't look like it's in the picture. Maybe, wait, maybe it'll. Oh, there it is with the standard deviation of 1 day. Okay. And then question A. On this one's actually written in words, so I'm going to have to write the probability statement myself. The A part says, what is the probability a randomly selected fertilized egg hatches in less than 18 days? So let me show you how I'm going to write that. I'm looking for the probability that the number of days, that's a data value, is less than 18. So on this problem, you have to write your own probability statements. So that's my X. So X equals 18. That's the data value we're looking at. So when I do step 1, let's do step 1. Step 1 is to find the z-score. This is your formula for finding the z-score. Step 1 is to find that z-score. So I'm going to, for X equals 18, I'm going to find the z-score. So I'm going to label that because I'm looking for a z. I'm going to say z equals, and X always goes first, so my X is 18 minus mu, which is 20, divided by sigma, which is 1. So that's going to work out pretty nice. I can actually do this one in my head. 18 minus 20 is negative 2. Divided by 1 is still negative 2. Now, if you wanted to see the two numbers after the decimal point, since that came out even, both numbers are 0. So there's our z-score right there. So step 2 is going to be to rewrite this. I'm going to do step 2 now. We're going to rewrite that probability statement with a z. It doesn't change the arrow. All we're doing is we're writing, instead of the data value, the z-score for the data value, which we just came up with, is negative 2.00. And that is step 2. Step 3. Step 3 is to draw your picture with z down here. And that z-score we just found, we're going to put on the picture on this number line at the bottom. Negative 2 is going to be over here somewhere. So I'm just going to draw a line there. I'm going to shade the area it wants. Since this is a less than problem, that means I'm going to shade to the left, not to the left of 0. In fact, you may want to leave that off and just put the 0 like right there so it doesn't confuse you. To the left of this z-score. So less than means we're looking for this area to the left. That's the question. Hold on just a second. Okay, sorry about that, guys. That was my office phone. Okay, so that's the area I'm looking for. I shaded it. Now I want everybody to practice using your z-table. What that z-table is going to give us is the area to the left, which on this question is all we're looking for because it was a less than question. And that the z-table does give you less than probabilities. So using the z-table, to look up negative 2.00, we're going to look on the negative page. We're going to look up the row for negative 2.0, which is about in the middle. So we're going to look at this row. And then the number in the hundredths place is a 0. So the column you're going to look at is the one that says 0.00. Not because of this. This is the number you're looking for. That one is 0 for all of them because the number in the tenths place is on the row. The only thing you're looking at on the column is to get the correct number in the hundredths place. So I'm going to cross-reference this row and this column, negative 2.00, and we get an area of 0.0228. That's the area in the table for this row and this column, and that's this area here. Now, on this particular problem, since the area to the left is the same as the area we shaded for our step 4, our calculation, there's nothing to do. The area that we were looking for, the probability that z is less than negative 2, is that number. And I'll pull the problem back up and we'll check and see if we got the answer right. So this is my final answer right here. Let's make sure we're very clear about our final answer. And you can see the correct answer there is 0.0228. Now, if you would like, I'll give you a minute and you can write down the questions. I'm just going to write the probability questions for the rest of these. And if you want, you can write down the questions and the answers if you don't want to look back at the recording later to see what the correct answers were. So I'm just going to write down, so it has parts B, C, and D. Yeah, B, C, and D. And if you want to write the answers down for these, that would probably be a good idea so you can check later to see what it is. So the B part says the probability a randomly selected fertilized egg takes over 22 days to hatch. So that one is the probability that X is greater than 22. The C part says the probability a randomly selected egg hatches between 19 and 20. So that's X is between 19 and 20. So that's a between problem. You're going to have to do 2 z-scores on that one. And then the D part says, would it be unusual for it to hatch in less than 17 days? So if you want to, you can write the answers down to this, or you can look at the answers later by looking at the very end of the recording that I'll probably have it posted by tomorrow. I have to send all of these off first and they do stuff to it so that I can post them. They basically get them posted on YouTube. You can see the recordings through online class meetings if you click on the menu bar and hit recording. So you can still see that. Before I put them in my stat lab. So you have access to the recordings, you just don't have access to the YouTube version until I get them back and post them in my stat lab. So these are the questions. Let me unshare that so people watching the recording can see. This was the question that an egg hatches in more than 22 days. This is the question, what's the probability that egg hatches between 19 and 20 days? And then the last question is the probability that X is less than 17 unusual? So you would want to find that. We just did the probability that X is less than 18. And that probability came out to this. So that's less than 5%. So even that is unusual, right? Less than 5% is unusual. So if the probability of it hatching in less than 18 days is unusual, then I would say the probability it hatches in less than 17 days is also going to be unusual. The probability should be even lower. You could go ahead and do it just because it's going to ask you for that answer, I think. So I'm going to share that back with you, and that's the last thing I'm going to do. I'm going to leave these for you guys to finish. I'm going to share it again so that you can see the answers, so you can copy those down. So you see that we already did the answer to part A is correct. The answer to part B, it says the probability that it hatches in over 22 days is also 0.0228. And then the between answer is 0.3413. And then on the D part, you have to find the probability and decide if it was unusual. And obviously it says it will be unusual because the probability is less than 0.05. So I'll leave that up in case some of you want to copy it, and I will have everybody's tests graded before the next class, and try to catch up. Make sure you don't get behind in chapter 5, because if you wait, it will be hard for you to remember what we did. So make sure that you catch up and get everything. You have a weekend, so I expect everybody to have 5.1 and 5.2 completed when I see you again on Monday. And you guys have a great weekend, and thank you for coming to class. I'm proud of your hard work.